Okay, let's go over our test that we took. We're supposed to, in number 1, find the right hand, and this is in feet per second. So if I find the area under a velocity, I get the change in distance, which will be in feet. So my units are going to be feet. Got to remember to put feet on them. And write 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is perfect because right, the first bar will be between 0 and 4. And second one will be 4 to 8, 8 to 12, 12 to 16, 16 to 20, and so on. Oh, so there'll be 8 bars. In the right side of this bar, the height is 32. Width is 4. Right side is 32. Right side is 30. Right side is 25. 20, 15, 9, 3, 1. So let's see here. 20 and 30 is 50, and there's 57, so that's a 107. 10 and 3. 107 makes 110, 120, 135. That's the total of these, and each bar is worth 4 wide, so times 4 is 400, let's see, 35, 70, 140, 140, and 400 is 540 feet. Left 4. Well, to make 4 bars, I'm probably going to do from 0 to 8, 8 to 16, 16 to 24, and 24 to 32, and left. So each bar is 8 wide, and it's left side of the first one is 35 high. The left side of the second bar is 30 high. The left side of the third bar is 20 high. And the left side of the last bar is 9 high. There's 4 bars. Times 8. 50, 85, 94. 720 and 32 is 752. 32 plus 720 plus 50, no, plus 4 times 8 is 32. 720 plus 32, 752. I better check that. I don't want to give you guys wrong answers. 8 times 9, 4. 752. C, midpoint, 4. Well, I got the 4 bars. Midpoint is 32. Midpoint is between these is 25. Midpoint between these two is 15. Midpoint here is 3. Each bar is worth 8 wide. So 25, 30, 40, 72, 75 times 8. 3/4 of 8 times 100 is 600. And last, T4. Well, T4 is L4 plus R4 divided by 2, but I didn't do R4. I could go back and redo R4, or I can just do T4, which is using 4 bars. So these places, so they're 8 wide, and the average of 35 and 30 is 32 and a half. Nope, excuse me. Average of 35 and 30. Yeah, 32 and a half. The average of 30 and 20 is 25. The average of 29 and a half is 14 and a half. And the average of 9 and 1, 10 divided by 2 is 5. And so we get this plus this. See, that's 46 plus another one, 47. And 30 is 77 times 8. 616 feet. Okay, that's number one. Number two, low value, right 3 or left 3 for this from 2 to 14. 3 bars. 1, 2, 3. To be low, I'm going to use bars that stay under, so I'm going to use the height on the right side of this one, which is 16, 24. That's got to be 20. So it's 1, 2, 3, 4, and that's in the middle. So 16, 17, 18. So I got a height of 18. This is 4 wide. The next bar, if I go to the right side, is about there, which is 2, 4, 6 about. And the last bar at 14 looks like it's about 4 high. So I have 10 plus 18 is 28 times 4, which is 80, and 32, 112. Approximately. And explain why this is a lower sum. On a decreasing graph, the right side will be lower. And sum is an underestimate for a decreasing graph. Okay, page 2. So the snow depth in feet after, and time is in hours, and we're going from 12 noon. And we're supposed to figure out total amount of snow at 8 p.m., 8 hours after noon. Well, they give me the total at 1, at 7, at 4. Then they tell me how much it increases between 5 and 8 and 7 and 8. So I think I'm going to go with the amount at 7, 2 1/4 feet, plus between 7 and 8, it increased by 3/4 feet, which means it's 3 feet deep. At 8 p.m., the snow is 3 feet deep. It's not increasing or decreasing. We don't know that for sure. We just know that it's 3 feet deep at that time. B, they want to know how much it increased from 1 in the afternoon to 4 in the afternoon. Well, 1, it was 1/3, and at 4, it was 1 1/2. So we have to take how much it was at the end, 1 1/2, which is 3 halves, and subtract how much it was at the beginning, 1/3 of a foot. So getting a common denominator, that's 6 minus 2 6, which is 7 6, or 1 1/6 feet increase from 1 o'clock till 4 o'clock. (1 p.m. to 4 p.m.) They want to know how much there was at 5 in the afternoon. Well, between 5 and 8, it went up by a foot and a quarter, between 5 and 8. And at 8, it was 3 feet deep. So it must have gone from something to plus the inch and a quarter makes the 3 feet that it was at 8. So if we take 1 1/4 away, we get 1 3/4 feet of snow at 5 p.m. And finally, between 4 and 8, see, 4 it was 1 1/2, at 8 it was 3, so it increased by, how much did it increase by? 1 1/2 feet, and that did it over 8 minus 4, over 4 hours. So that means 3 halves divided by 4 or multiplied by 1/4 is 3/8 feet per hour. So on average, there fell 3/8 feet of snow per hour between 4 p.m. and 8 p.m. Okay. 4. We have an even function, so it's symmetric on either side of the x-axis. So from -2 to 6, -2 to 6, it's a total of 9. From 2 to 6, it's -2, which means from -6 to -2, it also has to be -2. And if there's 9 between here and here, and -2 here, there must be 11 here. 11 minus 2 is 9. If it's 11 and it's symmetric, must be half 11 here, which is 5.5 and 5.5 there. So how much is there between -2 and 0? -2 and 0 is 5.5. From -6 to 0, that's 5.5 and -2, or 3.5. And between 6 and 0, that's going backwards. You're supposed to go 0 to 6. There would be 5.5 minus 2, or 3.5, but it's backwards, so it's -3.5. Page 3. Well, when there's addition or subtraction in the denominator, it is extremely bad unless we can do some reduction. And we got x minus 2, and in the denominator, oh, there's an x that we can factor out, and we get x minus 2. These cancel, and we get 1 over x. So the antiderivative of this, in general, is going to be the antiderivative of 1 over x, which is ln absolute value of x plus c. Five minus pi is just a constant, so we can pull it out. 5 minus pi times 1 over the square root of 1 minus x squared. And you should recognize that as the arc sine's derivative, and it's times a constant, so it's 5 minus pi times the arc sine of x. Okay, the next one. 4 over the cube root of x. That's the same as 4x to the minus 1/3. So if we increase the minus 1/3 by 1, we get x to the 2/3. But then we're going to have to divide by 2/3, which is the same as multiplying by 3/2. So we got 3 times 2 is 6. 3 times 4 is 12, divided by 2 is 6. That's the first one. And secant tangent is the derivative of secant. And the 3x squared is the derivative of x to the third plus c. Derivative of negative cosine x is sine x. And the derivative of cotangent x is negative cosecant, so I need to put a negative on it, so it's a positive plus c. And finally, we have x. I'm going to I'll take that later. I got x to the minus 1/2. So if I move it up, so I'm going to take this all times x to the minus 1/2. And that's x to the 1. And when you multiply, you add the exponent. So we get x to the 1/2 minus x to the 1/2 times x to the minus 1/2 makes x to the 0, which is 1, and x to 5x squared times x to the minus 1/2 is 5x to the 3/2. A half off of 2 is 3/2. Antiderivative of this will be x, add 1 to that, 3/2 divided by 3/2. Since it's divided by 3/2, you invert and multiply and make it multiply by 2/3. Antiderivative of minus x is minus 1 is minus x. Antiderivative of this, so we're going to go x to 1 more than 3/2. 1 more than 1/2 is 2/2 or 5/2. And we've got 5, and we have to divide this by that new number, 5/2. So the 5's cancel, and so we get 2/3 x to the 3/2 minus x plus 2x to the 5/2 plus c. Exactly. Okay. So secant squared is the derivative of tangent x, and x to the third is antiderivative is x to the 4th over 4. And we're going to evaluate it from -1 to 1. So we get tangent of 1 minus putting 1 in there, we get 1/4 minus tangent of -1, and -1 to the 4th, we got minus 1 to the 4th is 1/4. So these are different, so we got tangent of 1 minus tangent of -1, and minus 1/4 plus 1/4 cancel out. (6b). So we got to do this absolute value. So x cubed, quick sketch here, is something that goes like this. The absolute value of it, this negative part gets flipped up here. So the area from -2 to 3 will all be positive. But if you just drop the absolute value and integrate from -2 to 3, you'll get negative area that would subtract from this positive area. So you need to split this into two integrals. This is 0 at 0. So we need to integrate from -2 to 0 x cubed dx, and that'll come up to be a negative area, and we need to make it positive by changing its sign. And then we need to integrate from 0 to 3, just a plain old x cubed, which will be a positive area. Now we'll see that play out here. Of course, the integral of x cubed is x to the 4th over 4. And if we evaluate that from -2 to 0, by putting in 0 first, we get 0. Putting in -2, we get -2 times -2, 4, 8, 16 over 4, or 4, and positive 4. And we're supposed to go 0 minus, put this in, subtract, putting that in. And -2 to the 4th is positive, so we're subtracting 4. So this is a negative number, -4. So when we change the sign, we get a positive 4. So there's 4 units of area down here, -4, up here, positive 4. And then we got to do the other part, integral from 0 to 3 of x to the 3rd dx, which is x to the 4th over 4, evaluated from 0 to 3. If we put 3 in there, 3 times 3 is 9, times 3 is 27, times 3 is 81/4. So this equals 81/4 minus, put 0 in there, you get 0. So we have 4 plus 81/4. Now 81/4 is 20 1/4 plus 4. So it's 24 1/4. 1/4. Okay, this one, 6c, we got to go from -1 to 0. We have to recognize, okay, so this is the, if you have gotten your note card correct, that's the derivative of the arctangent of x. And this is like 1/2 e to the x, and the half just pulls, is a constant, pulls out, so it's just 1/2 e to the x, the antiderivative. We have to evaluate that from -1 to 0. Exactly, so we put 0 in, we get arc tangent 0 plus, put 0 in here, e to the 0 is 1, plus 1/2, minus, now we got to put the -1 in. I forgot to make a vertical bar there. Put in the -1 and we get arc tangent -1, and put -1 in here, and e to the -1 is 1 over e times 1/2, so it's 1 over 2e. So put that in there, and we're supposed to subtract all of that. Now, you didn't have to, you could have left it there, but arc tangent of 0. What angle has a tangent of 0? Well, the y has to be 0 because it's sine over cosine, so it's right there, which is 0 radians. So we got 0 plus 1/2, or 1/2. And what angle has an arctangent of -1? Has a tangent of -1, that would be negative pi over 4. So the minus of pi minus pi over 4 is plus pi over 4. And then minus this would be -1 over 2e. Again, you didn't have to go that far. That would have been an okay answer. Fourth page, number 7. So capital F of t is the antiderivative of this. So the antiderivative of 4t, we raise the power from 1 to 2 and divide by 2. 4 divided by 2 is 2t squared. If I took the derivative, it's 2 times 2, 4, t to the 1 less 1. Antiderivative of this, we add 1 to the 2, and we get 5t to the 3rd, but we have to divide by the 3, plus c in general, and that would be f of t, except you can use this fixed point to figure out c. If I put -1 in for the t's, I get 2 minus 5/3 plus c. And when I put in -1 into this, I'm supposed to get 2. So if I subtract 2 from both sides, I get -5/3 plus c is supposed to be 0. So c would have to be plus 5/3. And so f of t in the end is 2t squared plus 5/3 t to the 3rd plus 5/3. So we have a graph, and I made a mistake here. I said feet per minute here and meters per second here. So I'll have to accept either feet or meters in our answer. Determine the change in the position between the 9th, 12, 15, 20, 18, 21, 24th minute right there. Well, pretty much looks like this cancels this. So all we really need to do is figure out how much this is, and it's negative. So that's 9 to 12, 3. And this height is -3, -4, average of -3.5 times 3 is -10.5. So right is positive is moving right, so this object is left, has moved left over these last. I mean, left minus left 10.5 feet if you use that one, meters if you use that one. determine the total distance traveled in the 27. Well, this is 24. Here's 27. Now, distance as opposed to position is just add up the areas. So this one looks like it would complete this rectangle. So I have 3, 6, 9 by 4 is 36. And I'm going to make it positive. That's for all of this. Each one of these is 18 and 18. They're negative 18, but we're doing distance, so we just add them up positive. And this looks like it's probably another 18. Looks like it matches these. So plus 18. So that's 54-ish meters, or feet, or meters, depending on which one we're working with. Evaluate this. So we got to put in minus 1. Minus 1 squared is 1. Over minus 1 plus 2 is 1. Then the next integer up is 0. So we put 0 in, and we're going to get 0 over 2, which is 0. Plus, then we're going to put in 1, and 1's 1 over 3. Then we're going to put in 2. 4 over 4, which is 1. And then we're going to put in 2, 3. 3 squared is 9 over 5. And then finally 4, the last one putting in. 4 squared is 16 over 6. So we got 1, 0, 1/3, another 1. So 1, 2, this goes in there, 1.8 or 1 4/5. So I have 1, 2, 3, and 6 goes in there, 2 and that would be 12, 4 left, 4, 6, 2/3. And I have 1/3. So 1/3 plus 2/3 is 1 plus 2 is 3. 1, 2, 3, 6 and 4/5. Put the 2/3 with the 1/3, making that be 3. 1, 2, 3. Plus 3 is 6 and 4/5, which is 6.8, if you will. All right. Best if you just notice a pattern, write what's going on. 20 is the first one. Then it's 20 subtract 3 to get the 17. And 20 subtract 3 twice to get this next one. 20 subtract 3 3 times to get the next one, and so on. And so it must be 20 minus 3 i's, and this one was 3 times 1, and this is 3 times 0. So I might as well just make I start at 0. So I subtract no 3's, then 1 3, then 2 3's, and 3 3's, up until I get to the end. Now, 20, 17, 14. 3 less is 11, 3 less is 8, 3 less is 5, 3 less is 2, and 3 less is minus 1. If I use I equals 0 here, and then 1, 2, 3, 4, 5, 6, 7, I equals 7 there. That's what I think is the easiest way to look at that. There are other ways to come up with this, and especially some of you want to start I at 1 every time. Let me do that. So if I start I at 1, there's a couple ways I could adjust this. One would be to say, well, let's do 23 minus 3i. So when I put 1 in, I get 23 minus 3, 20. But then if I start I at 1, this would be 1, 2, 3, 4, 5, 6, 7, 8. I'm going to stop when I is 8. You can check yourself here. Put 8 in. 3 times 8 is 24. 24 from 23 is minus 1. Put in the 1. 23 minus 3 is 20. The start and end work out. Okay,